Figure 10 shows the estimated blood flow through some parts of the body when a person is at rest and during exercise. So you can see at rest, during exercise, estimated blood flow. So brain stays about the same. That's important because if you had loss of blood to the brain, you could pass out. Heart muscle increases massively during exercise. Digestive system, well, it reduces during exercise because you don't need to activate your digestive system if you're running. Other muscles obviously massively increase during exercise. It's all about your heart and muscles. And all other organs except your lungs show roughly the same. These are your vital organs that are needed to keep you alive. So it's always important to have a look and see the important things. I highlighted the increases in red, decreases in blue, and things that stay the same. It just gives you a much better overview when I'm coming to discuss it. It says, compare the rate of blood flow through the body when this person is at rest and during exercise. So it says through the body. So during exercise, the same blood flow through the brain and all other organs. So we just look, there are 3 points here. 1, 2, and 3. That's all we're talking about. Increased blood flow through heart and other muscles, and decreased blood flow through the digestive system. So if you just had a look at this first, you can almost predict the question that's going to come up, and it's so much easier to answer when you've processed it. Right. Explain why there is a change in the rate of blood flow through the digestive system during exercise. Well, quite simply, we don't need to have our digestive system operating at full speed if we're running. We need our blood to deliver oxygen and glucose to our muscles for respiration. So actually you answer this not so much by focusing on the digestive system, that becomes tricky. It's more about saying that we need more blood flow. If you accept we have a limited amount of blood in our body, we have an increased blood flow to the muscles to allow for respiration. That's that process that supplies energy to our cells. And that energy is used for muscle contraction during exercise. The stroke volume is the amount of blood leaving one chamber of the heart per beat. From which chamber of the heart does this volume of oxygenated blood flow? So, if you think about how this works, blood comes in from the body, deoxygenated through the right atrium. It then goes through the right ventricle where it's pumped out to the lungs. It gets oxygenated. It comes back through the right ventricle, then through the left ventricle, in an oxygenated state, and then out the aorta to the rest of the body where it's used up in respiration, and then this process starts again. So which chamber of the heart does this volume of oxygenated blood flow? Left ventricle, this one here, with the thickest muscular wall to pump blood with enough force that it reaches all the way down to your feet and all the way to, against gravity, to your brain. A person has a cardiac output of 4.9 litres per minute. The stroke volume of each heartbeat is 70 mils. I think there's only there's 2 or 3, depending if you're doing triple, equations you need to know in biology, and this is the other one. Heart rate, cardiac output, and stroke volume. So basically you need to know that cardiac output, which is basically the volume of blood that circulates your body in a minute, is equal to stroke volume, the volume of blood leaving your heart in one beat, multiplied by heart rate in beats per minute. So if we're trying to work out this, the heart rate, this one, we need to rearrange this formula, this equation. And we can do that by using, you can either do the 632 method. So for example, if you're not sure how to do that, you just get, you go, right, what numbers make sense here? Well, I'm going to say if this was 3 and this was 2, this would equal 6, because 6 equals 3 times 2. Now I want to work out heart rate, which is 2. So how do I get 2 from 6 and 3? I divide 6 by 3. So to work out heart rate, I do cardiac output by stroke volume. And if I do that, cardiac output divided by stroke volume, I get heart rate, which is 4.9 litres. And this is where you have to take care, because obviously this is litres, but the answer, cardiac output is in and stroke volume are in millilitres. Millilitres per minute are millilitres. So you have to convert litres to millilitres. If you're not sure how to do that, it's quite simple to do unit for conversions. You just need to know that 1,000 millilitres equals 1 litre. So if you know that, then you just have to say to yourself, right, so how do I go from litre to millilitres? I times by 1,000. The other way around would be dividing by 1,000. So what I've got here is litres, so I need to times by 1,000. So millilitres is 4,900 divided by the stroke volume, which is 70, which equals 70. 70 beats per minute. And it's important that you sort of just check this figure, because we're talking about a heart rate. If you've got a number like in excess of 200, you know that can't be right, or something way below 30, that doesn't sound right either. So 70 sounds like the right, if you say that a heart roughly beats once per second, that seems about right. So just be aware of this. This is also something which is coming up very, very frequently in exams, unit conversions. So make sure that the units are standardized. Litres and millilitres won't work. You have to convert 1 to millilitres in this case.